Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilman bin Zuki. Today, me and my friends, Chok Jinjing and also Muhammad Zafi, will be presenting our project A and project B, which is first is AC to DC converter from 240 volt to 5 volt using bridge rectifier, and the next project is water level alarm system. So, without further ado, let's get into project discussion.
So hello, I am Chok Jingjie and I will be doing the introduction for project A from group 13. So project A will be making a AC voltage input to DC voltage output. To make such a circuit, we will need four main parts: a transformer, rectifier circuit, then a filter circuit, and lastly a voltage regulator circuit. So for the first one, the transformer circuit. Transformer, we have two types of transformer. The first one, step down transformer, and the second one, step up transformer. In this project, we will be using a step down transformer where the input from the our normal voltage is the 339 watt mean square voltage for Malaysia household. We will be stepping it down to 16.9 watts using a bigger primary coil number from the secondary coil. Then for the second part, we'll be using rectifier circuit by using four diodes. The diode we use is 1N4002. Rectifier circuit converts all the normal double phase to a single phase, where the normally AC voltage will be have two phase like this. Then it's now only one phase. Then after rectifying the circuit, we will use the capacitor as our filter circuit. Here the capacitor, and the capacitor functions to smoothen the voltage. So you can see it's more smooth because when the voltage decrease, capacitor will discharge and make it more smoother. Then for the last part, we will have a voltage regulator circuit, which normally people use integrated IC for this, but we use the Zener diode because we cannot find the model for LTSpice. So this thing changes the smoothen voltage from filter circuit to a constant voltage, which is usable. Then the final output for our circuit is 5.1 watts. That's all from me. Thank you.
So next is the schematic circuit and also the board file. So this is the schematic circuit. As you can see, it starts with a supply socket. This is connected to the 240 volt AC source, and next to it is two test points. So these two test points can be connected to a channel in oscilloscope to see the sinusoidal graph of the AC suppliers. And then next to it is a step down transformer, and next to the step down transformer is the first test point for the circuit, which is the input test point. So next to the input test point is the bridge rectifier, which consists of four diodes, and next to the four diodes is a capacitor. So the capacitor works as a filter to smoothen out the output which is given by the bridge rectifier. So next we have resistors connected, and there's a LED. So the LED acts as an indicator to show the output, whether we got a DC or a smooth DC output. So next to it is below it is ground test point, and next to it is an output test point. So at the end of the circuit, there's a Zener diode. Zener diode connected in parallel. So the Zener diode acts as a voltage regulator due to its properties, such as it allows reverse backward at some points. So next we will go on to the board file. So this is board file. The size is 47.93 cm times 24.15 cm. So this is the board file. The first test points, the first two test point is located next to the point which the transformer will be uh, connected to the circuit. So next is the four diodes, and above it, as we can see, there's 2 points, which is the ground test point and also the output test points. Next is the components which are present as stated in the schematic circuit before. I think that's all. We'll be moving on to project B.
Hi, I am Mohammad Zafiq Zaimi bin Arba'i from Electrical and Electronic Program. I'm also from Group 13. We'll explain about our project B that we are assigned to build a water level indicator to detect at least 3 different levels of water. For this project, we use 4 basic components from our kit, which is light emitting diode LED, resistor, transistor, and buzzer. For this project also, we use 220 ohms value of resistor to avoid the LED to burns, and NPN types of transistor. This is our schematic diagram. How this works? The circuit is designed to indicate 4 different levels of water stored in the tank, which is low but not empty 25%, half 50%, more than half but not full 75%, and the last full but not overflow 99%. When there is no water in the tank, all LED are off. When water level increase and reach point B, the contact point A and B get a short circuit, and the water acts as a conducting medium between A and B point. This will turn on transistor and LED white start to glow up, which is 25%. For 55 and 75% level, the situation was same. Point C and D get a short circuit. Green and yellow LED will glow. When the water increase and reach last point, the red LED 99% glow, and also an alarm made by buzzer SLs indicate that the tank is full and the water pump or the motor need to be turned off. This is both circuit. From the ECAL software, I get a size 1.99 times 0.9 inch. I will show demonstration for project B.
So this is my demonstration for project B. So as you can see, this is what? So next is percent. Next is at 75%. Lastly, so the buzzer, and the last is when it's near to full. I think that's all.